Hello and welcome. This is a new episode from Aero Arduino, and in this episode, I'm sharing with you how to connect the PIR or passive difference sensor with Arduino, and I'm using that on Tinkercad Simulator. If you didn't yet subscribe, please subscribe to our channel to get the latest videos. Many of our friends have asked me about how to connect the PIR sensor to Arduino, and today we are discussing how it works, a little bit physics. Okay, we know that most or all bodies emit or all objects emit infrared radiation. Okay, and this sensor doesn't need any active infrared source like remote control or anything. It detects motion by having a two separate infrared receivers sensors inside it. So it detects the emitted infrared from all particles or all devices or all objects around it, and then it measures the infrared it receives and then detects if there is some motion around it. Okay, and so there are two setting, okay, like screws. We can adjust the sensitivity of this sensor to know where to locate the motion. And the other screw that sets the delay, because when it senses any motion, it provides a pulse, and this pulse can be triggered to a selected time delay. So we can select the delay that we want according to this screw setting. Okay, so now let's see how we can connect it to Arduino here on Tinkercad and also in the real world circuit. So we can connect this sensor to Arduino here in Tinkercad by connecting the ground pin to Arduino ground and then the power to Arduino VCC or 5 volts, and then the signal or the output from the sensor to pin number 5 on Arduino. This is how we connect the sensor. And also, we see the output on an LED. We connect the LED to Arduino. Here, the cathode or the negative pin connected to ground pin. This is the shorter one. And the anode, of course, it's the longer one or the positive. We connect it to Arduino pin number 9 through a 1 kilo ohm resistor to prevent damage to LED and also to prevent damage to the pin of Arduino. Now we go to the code to see how we can code the software for this sensor and how we can use it. First, we initialize the constants. Const LED pin number 9, that we define that the pin number 9 is connected to the LED, and also constant integer sensor pin number 5, we define it as the sensor here, and then we define a variable for state of the type integer. We initialize it as low. This means that there is no motion detected. And also here we see the value. We initialize it to 0 and it's of type integer as well. Then we go to the void setup function where we set up the pin mode for the LED as output and also the pin mode for the sensor as input. So we take the input from the sensor to Arduino here. And also here we initialize the serial begin, the serial monitor using the serial begin function Here we see the serial monitor where we can debug the project and see what Arduino is actually seeing. Then we go to the loop function where we provide or we perform our program. First, we define the value to be the digital read function from the sensor. Then we read the value here, the value detected from the sensor, and we define it as the value. So we check using the if statement. If value is high, equal high, then the LED will be high as well. So we initialize the LED, we set it as high. So when it gets the high pulse, then the LED will be high as well. And then delay of 500 microseconds, that means half a minute. Okay, and then if state is low, then the serial print. If the state is low, we put after that delay, we check the state, then we print that motion has been detected, and then we set the state too high. Otherwise, we make the LED low. That means that there is no motion detected, and here the delay is 500 milliseconds as well. So if the state is high, that means that there have been a previous motion detected. Then we print the motion action has stopped. That means that the trigger has stopped. And this is the delay that we get from the sensor by setting the delay on the screw that I mentioned for you. Then after that, we set the state to low as we finalize the cycle and start a new one. Now let's see how we can simulate the project. We press start animation. Here we see the serial monitor. There is no any action here. Okay, it's stopping. It's not making anything on the serial monitor. But here, when we click on and we move target, it checks that there is motion detected, and also it makes the LED on. Then after half a minute, it turns off. Sorry, half a second. It turns off the LED, and then when we move again, there is a pulse output from the sensor, and then it triggers LED to be on, and also it makes that on the serial monitor. It writes motion detected, and then motion has stopped, and then it starts a new cycle. As we mentioned before, the delay of the pulse width coming out from this motion sensor can be adjusted using the screw that has been designated as a delay. This is how we can use the PIR sensor with Arduino on Tinkercad. If you like this video, please click like, share, and subscribe. Thank you and goodbye.